Assalamualaikum and good afternoon everyone. So in this video we're going to look into chapter 6, which is the repetition structures. The objective for this chapter is for you to be able to write and use for loops, while loops, create midpoint break structures, measure the time required to execute program components, and also understand how to improve program execution times. So let's look again at this structure. I think I have shown this structure in our previous chapter. So as we have previously discussed, the one way to think of a computer program is to consider how the statements that compose it are organized. So usually, the sections of computer code can be categorized as these three structures: the sequence, selection, and repetition. So the sequence is what we have done until before the selection. Okay, so sequence, as the name suggests, says that all the statements or commands that need to be executed will be executed right after another. And then for selection, when meanwhile, for the selection structure, the statements or function or command will be executed if some conditions was true or was false or maybe not at all. Meanwhile, in this chapter, we are going to focus on this repetition structure, or oftenly known as loops. So loops are actually a new control construct that makes it possible to repeat a block of code a number of times. So MATLAB supports two types of loops: for loops and while loops. Okay, there are actually distinct difference of when we will use for loops or when we will use while loops. But the basic is we use for loop when we know how many number of statements, how many times that we need to repeat that certain statements. And then we use while when we do not know how many times that the statement will need to be repeated. So in general, loops are best used with scalars or with the values stored in a matrix, used one at a time. However, in many cases, you can compose MATLAB programs and avoid loops, either by using the command find, the find command, or by vectorizing the code. As this is true especially when we are working with vector of matrices. So the most frequently repetition structure used is this for loops. The structure of the for loop is simple. Okay, as shown here, the first line identifies the loop and defines an index. This first line here. So index is a number that changes on each pass through the loop and is used to determine when to end the repetitions. So after the identification line, here comes the group of commands that we want to execute. And then finally, the end of the loop is identified by this command end. The loop is executed once for each element of the index matrix identified in the first line. So let's see this example here. This is an example flowchart for a for loop. So we can see that it consists a diamond shape here, which reflects the fact that a for loop starts each pass with a check to see if there is a new value in the index matrix. So index matrix will be included here, and then MATLAB akan check lah if there is a new value inside the index matrix. If ada new value, dia akan repeat. Okay, every time dia ada new value, dia akan repeat. But bila MATLAB check and then dia tak ada jumpa a new value, so if there is not a new value anymore, loop ni is terminated. So dia akan keluar from for loop ni, and the program continues with the statements after the loop. Okay, so let's see this simple example. So in this example, okay, matrix K137 is the index matrix, okay, which we identify in this first line here. Okay, this is index matrix that we identify in the first line for a for loop. And okay, and then after that, this is the commands that will be executed, and then end. Okay, so let's see. After you type this for loop and then run you punya program, okay, command window will return these 3 different values of K as a result. Okay, the meaning of this is actually, okay, so during the first pass through the loop, okay, MATLAB will assign a value of 1 to K. So the first value of the first value of 1 ni is, sorry, the number 1, value 1 here is the first value in the K matrix. Okay, after that, next pass, okay, second loop, the value of K is modified to 3. Okay, first value dia K1 ni kan, lepas tu dia enter lagi looping tu, dia akan tukar value K tu kepada 3. Okay, and then next loop dia akan modified and assign value 7 to K. So that's why this example code returns 3 different value of K on command window. So the index in this K, index tu apa? The index in this example is K here. Variable K here is the index. So programmers often use K as an index variable as a matter of style. So normally programmers, atau bila kita nak develop program using for loops ni, kita akan guna variable K ni as our index variable. It doesn't have any meaning, just style. Okay, so you can also define index matrix with the colon operator, or indeed in a number of any other ways that we have learned. So let me show you an example when we define index K using the colon operator. Okay, so on the first line here, okay, the first line here, for K equals sign 1 colon 3, okay, we define K as the matrix, as the index matrix, okay, 1, 2, 3, okay, tapi kita tak tulis dia as 1, 2, 3, tapi kita gunakan colon operator. So the first time through the loop, okay, MATLAB will assign K a value of 1. Okay. Lepas tu, since K ni value dia 1, so dia akan calculate lah. Ni calculation yang dia buat. Okay, ingat first pass, MATLAB assign value 1 kepada K. Okay, sekarang K 1. So, as output akan A akan dapat value 5. Okay, next pass, MATLAB akan assign value K as 2. Okay, yang ni A5 ni is for K equals to 1. And this one is for K equals to 2. Okay, so when K equals to 2, the A will be 5 square. So 5 darab 5 adalah 25. Okay, and then MATLAB akan check whether ada new value tak inside the loop. Okay, so ada. So K is assigned to a value of 3. So when K is assigned to value of 3, the A will become 125. Okay, so that's why the value of A is displayed 3 times in command window, because the statements in the loop, okay, ini statements in the loop ni, A ni, is repeated 3 times. So, although we define K as a matrix in the first line of the loops, because K is an index number used in the loop, it can be equal to only one value at a time. So if we call K after finishing the loop, it has only one value, which is the value of the index the final time through the loop. Okay, for example, here we have the previous example. So we just change the index variable K. Okay, so now we define it using the colon operator, and then this is the statement, the calculation that is inside the loop. Okay, so when I run this code, okay, I can see the variable A is being repeated or is being displayed 3 times in the command window. Okay, this is because the index variable is 3, 1, 2, 3, so 3 kali kan. Okay, however, bila kita call, kita nak tahu the final value of K tu, so kita type K, enter. Okay, kita hanya dapat the final value of K. Okay, maksudnya K hanya ada satu value sahaja from command window. Okay, you boleh check dekat workspace window ni juga, dia hanya ada satu value saja. Dia tak tunjukkan ketiga-tiga index variable untuk K tadi. Okay, now let's get back to our slides. Okay, so the most common ways to use a loop is to define a matrix, okay, like this example. So this loop defines a new matrix A, one element at a time. So since this program repeats each set of instruction 5 times, a new element is added to the A matrix each time through the loop. So kita akan dapatlah tengok. Okay, so kita define index matrix as 1 to 5 here. So every time the program tu repeat instruction ni, okay, dia akan tambah a new element to the A matrix. Okay, you tengoklah the first set hanya ada satu value je. So second set ada 2 elemen, third set ada 3 elemen, and then finally lah sampai dia complete 5 sets of repetition, and then dia matrix A ni akan ada all these 5 elements. Okay, so here kalau K tu is assigned to value 1, so the first element of matrix A is 1, 0, 2, 1. And then if dia akan masuk balik dalam loop, dia check lah. So for K equals to 2, okay, sekarang dia assign K to number 2. So the second element of matrix A is 2 to the power of 2 and then 4. Okay, so dia akan kekalkan yang sebelum tu and then just tambah a new one here. Okay, so new one here is depends on this index matrix that were defined. So hints. So most computer programs do not have MATLAB's ability to handle matrix so easily. Therefore, they rely on loops similar to the one just presented to define arrays. It would be easier to create the vector A in MATLAB with the code shown here. Okay, because it will returns okay, K 1, 2, 3, 4, 5 and A equal to 1, 4, 9, 16, 25. Okay, this is actually the example of vectorizing the code. So why we want to vectorizing the code? Okay, because sometimes bila kita deal with large lines or the large matrix, okay, vectorization makes MATLAB execute the code faster, so it is more efficient in MATLAB. So here is another common use for a for loop, which is to combine it with an if statement and then determine how many times something is true. For example, in this list of scores shown here, in the first lines, how many are above score 90? So the variable count is initialized as 0. Okay, so ni count ni, the variable count is initialized as 0, and then each time through the loop, if the score is greater than 90, the count is increased by 1. We then use length command to determine how many times the for loop should be repeat. Okay, so length command here akan determine berapa kali loop ni akan being repeated. So here you can notice that the length is equal to 4, which is the number of values in the scores array. Okay, so kita boleh try on our editor file. Okay, so here we have a vector of scores. Okay, first kita initialize our variable count here as 0. So, and then kita akan guna for loops ni. So the loops ni, okay, K ni kita punya index variable kan. So the index variable ni kita akan start with 1. Okay, and then kita akan guna length scores ni to determine berapa kali that the loop should be repeat. Okay, so length scores ni is actually the number of values in the scores array, which is the 4. Okay, so what happened is each time through the loop, if the score is greater than 90, the count is increased by 1. Okay, so yang ni dia depends on how many numbers of scores, and then if scores K ni is greater than 90, counter ni akan bertambah 1. Okay, so kalau kita briefly look at the score, kita tahu hanya ada 2 saja skor yang lebih 90. Okay, jadi through the for loops here, okay, ni with display count ni dekat command window will return result as 2. Okay, so for example first pass, okay, the start count ni kosong kan, so with first pass K is assigned as 1. Okay, tapi dia akan check score ni, is it greater than 90? Okay, so 76 is not greater than 90. Okay, so counter ni takkan tambah 1 lah. Okay, and then dia enter lagi for K equals to 0, so dia akan check untuk second element ni pula. So 45 is not greater than 90, so count ni tak tambah 1, dia still kosong lagi dekat sini. So after 2 pass, the count is actually still 0. Lepas tu kita enter sekali lagi to check this element number 3. So we know that 98 is greater than 90, so count akan tambah 1. So now count ni yang previous ni kan kosong, new count yang ni adalah new count sama dengan previous count plus 1. So new count adalah 0 tambah 1, 1. Lepas tu dia akan enter lagi loop tu and then check. So now kita tahu 97 is greater than 90, and then count tu akan increase by 1. So new count adalah last count, 1 tambah 1, 2. So that's why kita dapat count dia being displayed as 2 in command window. So we can summarize the use of for loops with these following rules. So the loop starts with a for statement and ends with the word and. The first line in the loop defines the number of times the loops will repeat using an index number. And then the index of a for loop must be a variable. The index is the number that changes each time through the loop. Although K is often used as the symbol for the index, any variable name can be used. The use of K is a matter of style. Okay, although kat sini dia kata you boleh guna any symbol for the index, tapi make it, saya minta standardize lah, kita guna K ataupun J pun okay, tapi jangan, atau I. Okay, tapi kalau boleh kita follow the style, okay, using K. And then you can use any of the techniques you have learned to define a matrix, to define the index matrix. The common approach is to use this colon operator. Okay, so if the expression is a row vector, the elements are used one at a time, once for each time through the loop. And if the expression is a matrix, which is not common, each time through the loop, the index will contain the next column in the matrix. This means that the index will be a column vector. So once you have completed a for loop, the index is the last value used. Okay, so for example here, I can show you what is the last value of a index. So if you call k, you can see the number is 4. And finally, for loops can often be avoided by vectorizing the code. Okay, tapi kalau boleh kalau dalam soalan tu minta you guna for loops, you kenalah guna for loops lah. Janganlah pandai-pandai tak naklah buat for loop, tak naklah buat repetition structure guna for loop. Saya nak guna vectorization atau saya nak guna find commands. No. So kalau soalan minta you guna for loops, okay, come out with the for loop program. Okay, so that's all.